Alright, so we're going to talk about section 5.7 and 5.8. We've already really kind of talked about section 5.7 with our graphing calculator exploration, where we're really looking at the transformations on quadratics, on parabolas. And then 5.8 is inequalities. So it's kind of similar to what we've done before, but with a little twist as we're looking at quadratics. So let's just review the transformations real quick. So if I'm given the parent function, which is y equals x squared, I also have what we call as the vertex form. So y equals quantity x minus h squared plus k. And this is going to be my horizontal shift, so the movement left or right is my h value, and then k is my vertical shift, so up and down. And if h is greater than 0, so if I'm subtracting a positive number, that moves it to the right. If h is less than 0, that moves it to the left. So we did some explorations with that and looked at how that works. And again, what we really think about is what's happening to our 0 value. So if I plug in h for x, that's 0, so that moves it to a positive h direction, so to the right. The vertical shift is kind of more intuitive. A positive k value moves it up, a negative k value moves it down. So if we have a parabola, I have the vertex, which in this case is a minimum at 0, 0, and if I shift it, the vertex becomes, I go over h, that's my horizontal shift, and then my vertical shift is up k. So the vertex is now hk. So this is why it's called vertex form, because if it's in this form, we can just by looking at it, by inspection, see what the vertex is. So the vertex is at h comma k. So an example of how that works, because it's not always going to look like that, is if I have x squared plus 8x plus 10, and I want to put it into vertex form. So I'm going to do it by completing the square. So I'm going to look at the x squared plus 8x and complete the square with that piece. So I'm looking at y plus something equals x squared plus 8x plus something plus 10. And the plus something is going to be half of the b value, in this case 8, and then I square it. So 8 over 2 squared on one side and 8 over 2 squared on the other side. Well, now everything is going to factor and simplify. So I get y plus 16 equals x squared plus 8x plus 16 plus 10. And x squared plus 8x plus 16 factors into x plus 4 squared. So that's the square that we built. If we were to look at what that square looks like, remember it has x squared, 8x, 8x, sorry, not 8x, 4x, 4x, and 16, and the sides are x plus 4 and x plus 4. So that's where the x plus 4 quantity squared comes from. Alright, and then I still have the 10, and I'm going to bring the 16 to the other side. So in this case I have y equals x plus 4 squared minus 6. And that's going to be my vertex form. So I have it in vertex form, which means that I can see from inspection that the vertex is going to be at negative 4 and negative 6. So if I was to graph it, I would have a vertex down at negative 4, negative 6, and I'm not sure yet if it'd be a maximum or a minimum, but if I notice that the coefficient in front of the x squared value is positive, I know that it's going to open up, and so I'm going to have a minimum value for my vertex. Alright, I also know the line of symmetry as at x equals negative 4. So that's my x coordinate of my vertex. If I was to draw the line of symmetry, it's where it splits it down the middle, and that's always going to be the x coordinate of my vertex. Alright, we need to add something to our complex number discussion, something that we didn't really hit in the book but is going to come up down the road, especially on our STAR test. We want to make sure that we have it out there. So if we want to graph a complex number, we have what's called the complex plane. We have a real axis, so that's our standard axis, and then we have an imaginary axis. That's what contains our I value. So remember, our complex numbers are the form a plus bi, and if b equals 0, then I just get a, which is a real number, so it gives me the real axis. And so we want to plot two complex numbers, 3 plus 2i, and 4 minus 2i, and it's really easy. All I do is I go over the real component, which in this case is the 3. So I go over 3, and then I go up the imaginary component, which in this case is 2i. So I'm going to go over 3 and up 2, and there's my point. So that's the complex plane point of 3 plus 2i. If I do 4 minus 2i, it's the same idea. I go over 4, and then I go down 2i. So that green dot is my point, 4 minus 2i. So they're really simple to plot, and it's something that, again, pops up down the road. All right, back kind of into the graphing quadratic stuff. So we have inequalities, and this is going to work very similar to how we did inequalities before. I want to graph y is greater than x squared minus 4x minus 5. And so to do that, I'm going to start with the vertex. So that's really going to be my maximum or my minimum. In this case, a minimum. So I'm going to take this and factor it. Alright, so I know where my roots are, and from the inspection I could figure out the line of symmetry and get the vertex. Or I could notice that the vertex is always going to be on the line of symmetry, and the line of symmetry is negative b over 2a. So in my case, that works out to be negative 4 over 2 times 1, or negative 2. So my line of symmetry is there at negative 2. To figure out the y-coordinate, I plug in negative 2 for x into my parabola. So it becomes negative 2 comma something. I plug in negative 2. Works out, I get negative 9. So the vertex is down at negative 9, and I know that it opens up because I have a positive coefficient in front of the x squared. Alright, so that's what my graph looks like. But I've been asked to graph y is greater than that. So if I look at it, I'm going to again pick a point, just like we did before. And I'm going to pick the point 0, 0 because it's easy to plug in. So I pick it is 0 greater than 0 squared plus 4 times 0 minus 5. Is 0 greater than negative 5? Yep, that's true. So that's a true point inside there at 0, 0, which means what I'm going to do is I'm going to shade inside. And I had to change it into a dashed line because it's greater than and not greater than or equal to. So it's really similar to what we did before. Get a graph, pick a test point. If the test point works, that's where you shade. If the test point doesn't work, you would have shaded on the outside of that parabola. Alright, but what happens if it's just one variable? So if I just had x, something that looks like this, x squared plus 7x plus 6 greater than 0. Same idea. First I'm going to start with the graph, and to do that I'm going to again find the line of symmetry. And so I get negative b over 2a, in this case negative 7 over 2 times 1, negative 3.5 is my line of symmetry. Alright, now I need to find the roots. So I'm going to factor, and we're in luck because this one will factor pretty easily, and I'm going to plot those roots. So I get negative 1 and negative 6 as my roots, or my zeros, and there's my line of symmetry at negative 3.5. Alright, I need the vertex. Well, the vertex is on the line of symmetry, so I plug in negative 3.5. And I see what I get out. Negative 3.5 squared plus 7 times negative 3.5 plus 6 gives me negative 6.25. So that's my y-coordinate. I plot that point. And I know that it goes up, again, because the coefficient in front of x squared is positive, as well as I have 3 points. And if I have 3 points on the parabola, it's pretty easy to see that this is going to go up. Alright, now this is where it's different than the other ones we've done before. I don't need to pick a test point. What I'm really looking at, what I'm curious as, is where are my y values positive? Well, they're positive. This is the y-axis, and there's the positive section of the y-axis. So I'm looking on the graph where that's going to be true. Well, there's my points where it's greater than it. So any x value that is either to the left or right of those points is going to give a positive y value. And since it's just, a positive x value, I'm getting something bigger than 0. And so if I look at my values, I'm going to have open circles and directions that go that way. So a little bit different, but same idea. You could pick negative 3.5 and plug it in and see what you get out. And you're going to get out something that is not greater than 0, so a negative number. And in doing that, you would test it as well. But this is another way to think about it, another way to plot these inequalities.